Hey, what's up, MakeOHI? This is Eric from Team Banana Bread, and we are excited to show you the project we have stayed up till 5 a.m. working on. So it's quiet hours, but that doesn't mean we're any less excited to show you.
3 bots, 1 arena. Garrett, Toaster, Felix. 3 robots enter the arena.
These are not battle bots. They are safety bots. Made to be the future of transportation safety, each robot represents a car in the real world. By giving each car cheap and efficient communication to cars nearby, our software can share position, rotation, and velocity information to predict and prevent future accidents.
At the very top of our project is a camera, which is supposed to represent a GPS in the real world, but we don't have cars and actual GPS circuits to use, so we used a camera to represent GPS instead. And we use these fiducials, or mini QR codes, basically, to track our cars around the floor. And by processing the image from the camera, we can figure out where every single car is, get its position, rotation, and calculate its velocity over a longer period of time. We can then send all this information to every single one of the cars, so the cars know where each other are, just like they would in the real world with this system.
In order to prevent our cars from hitting each other, they need to be able to communicate. And ideally in the real world, this would be done with radio. But because that's a lot of work and we're just working in a small area, we opted for a Wi-Fi network instead. This is the heart and soul of our network. This is the Banana Bread Wi-Fi network on a little Wemos. And on each of the cars, there's a little Wemos. And there is Python scripts on each of the computers, on the GPS, and on the controller script that can communicate directly with the bots through interfacing with the custom DNS we built on the Banana Bread home network.
So, finally, we have our representation of, well, the car. These are tiny little Wemos-powered, I guess, human-controlled vehicles that we use as the substitute for our cars. It took a bit of working to get these, well, connected to everything. The main issue was mainly just getting them into a form factor that looked and felt like a car so that we could actually, like, simulate the real-life scenario. We started off by, well, drawing out a circuit diagram. This would be basically everything that would drive just the main motor itself, without rotation, which we handled with a servo at the back of the vehicle, because our first prototype, we ended up putting the motor the wrong way, and we decided to just stick with it because it was easier than undoing all of the hot glue that we had used as insulation and redoing the other robots as well. So we have front-wheel drive with rear-wheel drive steering.
All right, to sum it up, it's a small start, but I think that implementing this kind of crash detection in the real world can really help increase the safety on our roads.
There was so much excitement throughout this event. Thank you to the organizers and the sponsors. We are so much very excited to see you again at Hack Ohio in the fall.